Okay, we're going to try this cone problem from another year of Fisher High School, I think 2016 Fisher High School final November exam. And let's just give it a try. How does this thing work here? Let's see here. Whoop. Okay, let's just figure. They say there's a bucket in the shape of a frustrum. I didn't even read that the first time, but it's called a truncated cone, a cone with the top cut off, as indicated in the sketch. Now, sometimes people they don't see the three dimensions here. What do we mean by a cone with the top cut off? Well, you know those cones that we've got those cones out there in PE in the field, and they look just like that. There's the cone, but it's like it's being sliced right here. But we're going to make a bucket. We're going to turn this upside down. That's going to be a closed part of the bucket. The outside of the cone right here is going to be the outside of the bucket, but it's a bucket, so the top must be open. So first you have to be able to see this. These are cones with the top cut off, and that's what's happening here. So let's see if we can get at this problem. Let's just try. Here it is. The big cone would go right down to there, but the top is being cut off. It's sort of turned upside down. This will be closed. That's a circle right there. That's the bottom of the bucket, and the top of the bucket, like all buckets, must be open. Okay, let's just get started here. The dimensions of the bucket are given here. The diameter is straight across the top is 20 centimeters. The height of the whole cone, if there wasn't the top cut it off, would be 30 centimeters. It's 12 centimeters, the diameter straight across the circle at the bottom of the truncated cone, at the bottom of this bucket, and it's 15 centimeters deep. That's how tall the bucket is. Okay, well, there's some things to figure out. The first question we're going to do is the volume of the bucket, the volume of the bucket. Well, they give you two formulas here. Well, it's pretty easy to see which one you should pick. There's V, the volume of the bucket. But to be able to do that, you need the radius and you need the height. Well, there's some things right here. Let's take a look at the bottom of this bucket here. If that's 12 centimeters, that's the diameter. And they say that 12 is the diameter, then half of it's the radius. You should be able to figure that one out. Now, to the very top of the cone, it's 30 centimeters, but the depth of the bucket is 15. Well, 30 minus 15, that little piece must be 15 centimeters. So the cone that was cut off, you see, there's a little cone on the top, and there's a big cone. That part that got cut off, the height is 15 centimeters. So our first problem is, and you might want to stop, once you could have stopped it right in the beginning and given it a try to find the volume of the bucket. But you had to figure out this radius right here, and you had to figure out that this was 15 meters, that top cone there. Well, the first problem, there's your formula. But what's the volume of the big bucket? Well, you should try it on your own right now. Just try it on your own. The volume of a big bucket. Your problem is, you can stop the video and try it. But what we're going to do, you need to find out what's the radius of the big cone. Well, the big cone, the radius is 10. What's the height of the big cone? Hey, there it is. The height is 30 centimeters. It's 30 centimeters. So just put those numbers in there. That is the volume of the big cone. Now, this part that got cut off, it's got a radius. You've got to figure it out. It's got a radius of 6. And the height is 15, see? Now, what do you think we should do? There it is, the volume of the small cone. You just put that into your calculator. And what would be the volume of the truncated cone with the top off? Well, you'd take the big one, and you'd take away the small one. That's how it works. In fact, that's exactly what you do. Now, I did a trick. You see, I see 1/3 pi in both, so I factor it out. 10 squared times 30 is 3,000. That's 36 times 15. I put that in my calculator, and I did put it in my calculator, and it told me that the volume of the truncated cone is 2,576.11, rounding that off, cubic centimeters. And that's it. That's the volume of the truncated cone. Okay, so there you go. That's the first part. We'll do the next part in another video.